Yes guys, so we are doing question number 8 here. So here NA, number of favorable event in A, because these are the 5 outcomes which are showing sum 6 out of the 36, right? This is 3, 3. So therefore NA, number of favorable cases in A is 5. Try to understand this. Now what is B event? Now B event is that number 4 has appeared once, at least once, but twice the number in the 6th sum is not appearing to. And B is the event 4, 2 and 2, 4, that means 2, 4 and 4. Only these two outcomes are there which are having 4 number at least once. Out of the sum, this is also showing sum 6, because we have to select these two outcomes from this A. Total outcomes are A. Therefore, probability of B with respect to A we have to find out. Therefore, let me write it above. Let me write it here. Therefore, probability of B. First, let me find out that what is therefore B intersection A. So, what is A intersection B or B intersection B? It implies that A intersection B are how many? A intersection B. How many outcomes are there which are common? These two only. This is 2, 4 and 4, 2 only. Only these two outcomes are there. And A intersection B is equal to, and A intersection B is equal to 2 only. But these two outcomes are there which are found in A also. 2, 4, 4, 2, 2, 4, 4, 2. Okay, these are showing sum 6, because B event was that at least once 4 has appeared. 4 has appeared at least once. So once, twice cannot be possible, because that will not be a show sum. 4 plus 4 is 8 sum. Okay, so that cannot be possible. So at least 1 means minimum 1. Maximum may also be there, but maximum 4 cannot appear, because that will not be a sum 6 then. 4 plus 4, no, not possible, because that will be a sum 8. That is not required here. So the event A is this total number of outcomes, and with this event B with respect to A has to have happened. So conditional probability of B when A has occurred first. Then what is the conditional probability? This will be. Now let me find the probability of this conditional probability of B with respect to A. Therefore, conditional probability of B with respect to A is number of favorable cases in A intersection B divided by number of favorable cases in A. Or this can be written as N A intersection B oblique NS, total number of outcomes, which is 36, divided by N A oblique NS, total number of outcomes. This is the major division sign here. Okay, this is what probability of A intersection B divided by probability of A. That is what, or directly we can substitute that. What is this total number? Common number is 2. 2 upon 36 upon, this was 5 here, 5 upon 36. 2 upon 5 is the answer finally. This is good. 2 upon 5 or 2 upon 36 that we write here. 2 upon 36 upon 5 upon 36. Why? Because in event A, total outcomes are, favorable events are 5. Because 5 outcomes are there which are showing sum 6. This is 2 upon 5, 36, 36 cancel out. This is 2 upon 5 here. The answer is 2 upon 5. So 5 A intersection B, which in the numerator conditional probability is given as probability of B oblique A, or with respect to A. Right, when A has occurred first, then B is occurring. So conditional probability of B when A has occurred first is equal to this number of favorable cases in A intersection B divided by number of favorable cases in A, or total outcomes in A. That can also be written as NA intersection B upon NS upon NA upon NS. NS means short number of outcomes, 36. 36 cancel out. The B can directly put 2 upon 5 is the answer. So answer here, conditional probability is 2 upon 5. Therefore the conditional probability therefore the conditional probability of B when A has appeared, A has happened already, A has occurred already, or A has already occurred. We can say A has already occurred. A has already occurred. So this is probability of B when A has occurred first is equal to 2 upon 5. This is 2 by 5. This is the answer here. 2 upon 5 is the answer, conditional probability of B. Okay, now let us take the next question. Question number 9. What does it say? Let me check it. Now please try to understand how to solve these conditional probabilities. Even first is occurring, then second is occurring. So with respect to the first event, what is the conditional probability of second event? That we have to find out. Let us take now question number 9. What is given to us? Now let me take with the question number 9. Question 9 says a fair dice is rolled. Fair dice. It says if fair dice is rolled, right, and consider the following, and consider, now try to understand, and consider the following, consider the following events, following events, and consider the following events. What are those events? Now A is a sample which contains 1, 3, 5. For dice is thrown 1. There are 6 total outcomes. 1, 2, 6. 1, 2, 3, 4, 5 up to 6. Okay, 1 up to 6. Or 1 to 6. This is what 1, 3, 5 is in event A. B is showing how many outcomes are there in B? 2 and 3 only. This is B event which is having 2 outcomes of the dice. Number 2 and number 3 from the dice. So B contains only 2 outcomes. C is how many C? And C is and C. And C is equal to how many? 2, 3, 4 and 5. No problem. 4 outcomes are there. Then find here. On the basis of these 3 outcomes, we have to find out, or 3 these sets we have to find out. Okay, drawing. This is drawing a red board. Okay. So question number 8 is this. Okay, so 9th question we are doing. Now come to the point. So what did we have to find out? To find the probability, and find first part, condition probability of what we have to find out. First is A, condition probability A oblique B, means when B has occurred first, and probability B when A has occurred first. Okay, condition probability of B when A has occurred first. Here probability of A when B has occurred first, no problem. So the 2 parts are here. Okay, then B part says, for the B part, in the B part says probability of A oblique C, right, and second part is probability of C oblique A, right, or C with respect to A when A has occurred first, and the C part, probability of A union B oblique C. This is very important one. Let me take this like this. Okay. So A union B with respect to C means when C has occurred first, then A union B is occurring. That is the question. Let us find out. Okay, A union B oblique C, and second part of this is probability of A intersection B oblique C. Okay. Now let me take these 2 events. So this is again C has occurred first, then A intersection B is occurring. That is the probability, and D part is also there. D part here, A intersection B oblique C, and D part say A intersection B. Okay, this D part is same thing I think as A intersection B intersection C. Okay, so this is also D part is probability of A intersection B oblique C. Again the same thing, just like this. So what is the answer of this? Probability of A intersection B oblique C. This is the C second part, and the D part is probability of A intersection B when C has occurred first. This is just like this one, no problem. Let us take all these parts. Now try to understand. In case of A intersection B, this A oblique B when B has occurred first, we have to find out what is A intersection B, A and B intersection, because conditional probability is given by, for example, this will be equal to probability of A intersection B divided by probability of B. In this case, this is probability of B intersection A and divided by probability of A. So what is B intersection A that we have to find out? Now in this case, A intersection C we have to find out, because in the numerator it will be probability of A intersection C divided by probability of C. In this case also probability of C intersection A oblique probability of A. This is C part, this second part of B. Now in this case, try to understand. A union B intersection C. So this is the one event in the numerator, A union B. So A union B undoubtedly we will calculate, and then we have to find out what is A union B intersection C. Reason is because this whole equal to conditional probability of A union B with respect to C will be equal to probability of A union B intersection C divided by probability of C. Okay. Similarly, this A intersection B intersection C here. So A intersection B intersection C in the numerator divided by probability of C. This is the value. And this is, I think, same thing, whatever this answer will be there. So D part is not required because that is the same part here. Okay. Probability of A intersection B when C has occurred first. So that is the same question. No problem. This is not required. Let me just rub this D part here, because D part is just like this. So D part is not there, only three parts are there, A, B, C, because this is repeated here. Okay. D part is just like second part of C, A intersection B, when C has this A intersection B oblique C, that means with respect to C, when C has occurred first, then A intersection B is occurring. Let me now find out. Solution. Now try to understand what is required here. Now we have to first find out A intersection B. Here A intersection B is equal to how much? Let me find what is A intersection B. A intersection B, only 3 is common, right? Because common between A and B, 3, no 2 common, no 1 or 5 common. Okay, this is only 3. This is only one number 3. So this is an A intersection B. Number of cases or outcomes in A intersection B is only 1. This 1. This is first part we will use. Then A intersection C will also be required. This is B intersection A, the same thing. A intersection B, B intersection A, same thing. This is 1, no problem. Now A intersection C, A intersection C or C intersection A, the same thing. Okay, this is also required. A intersection C, A intersection C, C is here. So this is 3, 5. Okay, 3 and 5, 2 are there. 3 and 5 are common here in C, A and C. A and C, this 3 and 5, 3 and 5, these 2 are common. 2 and 4 are not common. 1 is not common, no problem. Only 2, so therefore this implies that n number of favorable cases in A intersection C or C intersection A is equal to 2. This is 2 here, 2 outcomes in A intersection C. Now let us take these 2 parts. A union B, this A union B intersection C. Why intersection? Well, in the denominator, whatever the part is there, intersection with that A union B intersection C So this will be required in the numerator of this probability. This will be how much? Let me see. A union B. These two are first added up. So this will be 1, 2, 3, 5. Okay, 1, 2, 3, 5. No problem. 1, 2, 3, 5. So 2, 3, 5, 3. 2. So these two are combined together. First A union B. This is A union B. A union B means 1, 2, 3, 3, common 3, 5. 1, 2, 3, 5. 4 outcomes are there. So this common between A union B intersection C. So what is the common? 2, 3, 5. 3 outcomes here. 2, 3, 5. Because 4 is not common. 4 is not found here. No problem. Only 2, 3, 5. So this implies that number of outcomes in A union B intersection C is equal to 3. Very important. Last one is this A intersection B intersection C. Now A intersection B intersection C. For this will be required. And last one. This implies that, okay, this is equal to this, A intersection C equal to this, A intersection B intersection C, A union B intersection C, A intersection B intersection C. Now try to understand. So the common between these three, A intersection B intersection C, common between these three. What's the common? 1, 3, 5, only 3 was common here, 3 is common here. 5 is not found here, so 5 cannot be taken, 2 is not common, only 3. Only one outcome is there, which is 3. But in all the 3, A, B and C, what is common? Only this 3 is coming in 3. 1 is not here, no. So 5 is not in second, B, not common. Okay, so only 3 is common. That is number of, this implies that number of outcomes in A intersection B intersection C is equal to 1. Alright. Now let us find what the conditional probabilities. Therefore, let me find this here. From here, let me find out solution. So, first part was probability of, the first part was in the 9th one, was the probability of A with respect to B. This is equal to probability of A intersection B divided by probability of B. Now, what are the outcomes here? In A intersection B intersection B is only 1, this is 3. This is 1. 1 upon total outcome, whatever are there, 6 are there. 1.6 upon whatever comes in the, so directly we can substitute because 6 will be cancelled out. Probability of B, how many B are there? Or B was having total outcomes 2. 2 and 3 only. So B is having 2 only. This is A. When B has occurred first, so B is occurring first, then A intersection B is 1, 1.2. This is the first answer. Part. This is part A. First part. Second part of this A is probability of B when A has occurred first. So this is equal to, because common between this probability of A intersection B, the formula is divided by probability of A in this case. Now A intersection B is 1, that we have just calculated. A intersection B is 1. Number of outcomes is 1. Favorable cases, number of favorable cases in A intersection B is 1 only. 1 upon probability of A. Now A is having how many? 3 outcomes, or A 3 outcomes, 1, 3 and 5. This is 3 here, total. 1 upon 3 is, this is the second part of the first A section. First part, second part. So this is 1.2, 1.3. These two parts are solved. So first part A is complete. Now let me take the second part B. Second part B says, second part B also having 2 parts. The first part of B is probability of A when C has occurred, probability of A, when C has occurred first is equal to probability of A intersection C upon probability of C. We could write number of A intersection B upon number of C, number of favorable cases in A intersection C divided by number of favorable cases in C upon that total number 6 is there, so that 6 is cancelled out upon NS cancelled out, because numerator also NS will come in this also, so directly I am putting probability of A intersection C upon probability of C. Here we write favorable cases divided by total number of cases. Favorable cases in A intersection C is 2 only. This is 2 upon 6 that we take. 6 is total outcomes, NS. Total outcomes, because one die is thrown once only. So once when die is thrown, 6 outcomes are there, total outcomes. So that is the point. 2 upon 6 upon PC. What is C is having? How many outcomes? C is having 4 outcomes. 2, 3, 4, 5. So 4 outcomes, 4 upon 6. 6 is cancelled out. This is 2 upon 4 is equal to 1.2. We always write prime factors. In prime factors answer. This is the first part of B part. Second part is probability of C oblique A, I think. C when A has occurred first. B part. Yeah, B part says, where is B part? Yeah, B part is probability of C oblique A. Alright. So this is again probability of A intersection C or C intersection A, no problem. So both are same thing. A intersection C or C intersection A. Same thing. Probability of A and C or C and A, no problem, upon probability of A. So this is again two were these outcomes in A intersection C, A intersection C. 2 outcomes are there. So 2 upon, directly we can substitute. What is A? A contains only 3 outcomes, 1, 3 and 5, right? So this is 3 here, this is the answer. Or 2 upon 6 upon 3 upon 6, 6 is cancelled out, 2 upon 3 is the answer. So both the parts of section B completed. So conditional probability of C when A has occurred first, of A when C has occurred first, completed. These 2 parts are completed. So let us take this answer 2 by 3 and the first answer by 1.1. The B part is also completed. Let me take now C section. Now section C of this is, let me delete this. Now section C. Now it contains probability of, you have to find out A union B, probability of A union B oblique C. This is the point here. This is equal to probability of A union B intersection C. This is to be understood because whatever numerator and intersection with denominator. So C intersection C. This value is A union B oblique probability of C. What is this? Now A union B intersection C. A union B intersection C is how many outcomes? 3 only. So 2, 3 and 5. So number of A union B intersection C is 3. This is 3 here. 3. This is 3 divided by PC. PC is 4, I think. C. Total outcomes in C are 4. This is the answer here. First part is completed. Second part of this is A intersection B oblique C. Okay, so this is probability of again A intersection B intersection C. A intersection B intersection C. Denominator value is put in intersection in the numerator divided by probability of C. Now let us take this. Now A intersection B intersection C is 1 only. So this 3 is common. So this is 1 upon finally answer is, what is C here? C contains how many outcomes? This is C. Okay, second part of C part. Yeah, second part of C part. So C is having 4 outcomes. 2, 3, 4, 5. So this is 1.4. So 1.4 is the answer. Already it is a prime factor to each other. So 3.4 and 1.4 are the answers of second part, sorry, first and second part of section C. So C part is completed. So only these parts are there. Okay, so this is 9th question we have completed. Now D part is probability of A intersection B A intersection B oblique C when C has occurred. So this is this kind, A intersection B oblique C. I think D part is similar like this. This is answer 1.4. D part is 1.4 answer. Okay, this is question number 9 we have completed. Now let me talk about what is question number 10. Now question number 10, what does it say? What is given to us? Let me first write it down. Now question number 9 says, sorry, this 10 says, 10th question is, a coin is tossed 3 times. A coin is tossed 3 times. No problem. This is 3 times. Let me write like this. 3 times. You find. But where to find out here then? The probability of, okay, to find probability of E oblique F with respect to F when F has occurred first, then E is occurring. The probability of E oblique F, or when E with respect to F in each of the following. Here, to find the probability of this in each of the following. What are the each of the following? Let me write. In each of the following. First part is A part says that E denotes head on the third toss. Head on the third toss. And F says head on the first. Head on the first 2 tosses. On the first 2 tosses. Alright, first 2 tosses. This is the, let me take first this A part, and then B part is also, C part is also there. B and C part I will take later. Let me first solve it. Now here, solution let me find. Probability E upon F we have to calculate in all the cases, A, B and C, but I have written down here A only, then B and C I'll write later, but first let me take this. Now what is the E event here? Now because a coin is tossed 3 times, the total outcomes are, S sample space total outcomes will be H, 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 D, H, D, H, D, H, H, then T, or 1 H is repeated, H, T, T, then T, H, D, T, T, H, and T, T, T. A total 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So total outcomes are 8. We've got 2 raised to the power 3. 2 raised to the power 3 means 8. So 8 total outcomes will be there if a coin is tossed 3 times. Now E says what? Now E says which are the outcomes which are in this head on the third toss. Try to understand. Head on the third toss means this is third toss, head on the third toss. This is also outcome, and this outcome is also there. On the third toss, head must be there. So 1, 2, 3, 4. Let me write them. If on the third toss, head is there, head must be there. This is H, T, H, no problem. T, H, H. Third toss is showing head. And the last one is this DTH, double tail and 1 head. Total 4 outcomes are there. What is F here? Now F says head on the 2 tosses. First 2 tosses head. So what are the first 2 tosses? This is first 2 tosses head means H, H, H is common. Because first 2 tosses showing head. The third is head or not, that doesn't matter. That is not given here. That may be head or may not be head. So this is the first case completed. First 2 tosses are head. First 2 tosses are head. This is H, H, T. First 2 tosses are head only. These 2 are possible.